Hello, everybody. We're going to take a look at Unit 5.2a today, and that is about, this one in particular is about the area of a square and the area of a parallelogram. So this is what the first picture looks like. We have this rectangle, and it's 26 units on one side and 16 units on the other, and we need to find out what the area is. So for this problem, and for all your tests, you can use the GED formula sheet. So this has area formulas on it. Tells you how to calculate the area of all these shapes: square, rectangle, parallelogram, triangle, trapezoid, and circle. And one thing it doesn't have that the WAMAP formula sheet has is illustrations. So you can use either sheet. If you are planning to take the GED, you'll have to learn the GED sheet, which is this. You've got one-dimensional measure, which is linear, two-dimensional, which is area, that's squares and such, and then volume, which is three-dimensional. But while you're getting used to using that, you can pull this up, and this is right here in the module. And you can use these sheets on any test that you take with me. And at this level, we get to use calculators too. So I'm still going to ask you to show me how you calculated your answer. But yeah, it's great to use a calculator. And we'll just focus on learning these formulas and what they mean. So area of a rectangle is one side times the other. They have L and W, so length times width. And this is actually really similar to the area of a square. You multiply one side by the other. And in a square, all the sides are the same. So they will just write that S squared. That's what we have up here in the GED form, S squared. But it's really one side times another side. And this rectangle, LW, is one side times another side. And even the parallelogram, they have here BH, base, and height. And we're going to find the equivalent square inside of a parallelogram and calculate that area, and that's how we will get the area of a parallelogram. You'll notice that when we talk about area, it's always square units, and square because we have two sides at perpendicular angles, 90-degree angle, and that's where we get the square. And you're always, like, even when you take the area of a circle, you're going to, the units will be square because you are finding the equivalent square shape to compare it to when you calculate those. And here we have area of a circle is pi r squared, so pi times the radius squared. So that's your squaring element. And then pi is the ratio of the circumference to the diameter. And that's what we use to calculate it. So area is always in square units, and you're always calculating two sides at a right angle. Well, it doesn't look quite right, but 90-degree angle. All right, so I'm going to go ahead with the WAMAP sheet here with the geometric formulas. And so rectangle is just one side times the other, and they write A, that's area, is equal to length times width. And then the P is for perimeter. So if you want to know what the perimeter is, it's 2L, 2 times L plus 2 times W. So basically, if you add up W plus W plus L, you'll get the perimeter. That's the distance around. And a quicker way to write it, a little more mathematically pleasing, is the 2L plus 2W. Okay. So you can use that for this problem. And we're going to use our calculator. So let's go back up to where the problem was. They don't list units here, but we've got 26. And turn on your calculator. 26 times 16. I get 416 on my calculator, and so that would be the number that we put in this box. 416, and that should be square units. So it's unusual they don't say what these units are, and that they don't have the square symbol in the answer somewhere. But I think it's because it's just beginning level. And that's how we're going to calculate that. So here's the tablet. I've got it written out here. So 26 times 16, we can even do it longhand just for fun. $416, that's what the calculator told me. A little bit quicker than I got it, but that's your answer, 416 square units. And so that's the first one. And we're going to take a look at the parallelogram question too. So parallelogram, area is base times height, okay, BH. And base doesn't have to be the bottom, but it does have to be where you have a line going up to the other side at a right angle. So often in these illustrations, like for a math test, they'll have a little 90-degree angle sign here. So you'll know this is a right angle, and that if we multiply this is what which is basically, well, it's not drawn to scale, but this is basically the width according to how it looks, and then this is the length. 54 units times 42, and that will give us the area of the equivalent square. And if you watch the video at Khan Academy, you'll see you can square this right up. And this much area in here is what you're getting. It's like you took the square and you pushed it to the side. And so when we calculate the area of this shape, even though it's not itself square, we base it on what the equivalent square would be. So we're going to multiply 54 times 42. Let me grab my calculator. Well, I guess I can do just 54 times 42. 2 times 4 is 8, and then 10, and then 4 times 4 is 6. 21, 8, 6, 2, 2. So I get 2268 square units as the area of that. And that might be a piece of property or something they're planning to develop. Let me just check my answer with the calculator while I got it handy. 54 times 42, 2268. Awesome, we are in. So that's how to calculate those. Please give these a try. Try a couple of different ones, and I'll find some worksheets to put in there for you to practice extra. But basically, the thing to remember is you need to have a right angle, right? So something here. Oops. So rectangle, usually all four sides are right angles, so we can do one side by the other. Parallelogram, you don't have, well, you could. Rectangle is also a parallelogram. But generally when they say parallelogram, you don't have 90-degree angles. That's kind of like a trick question you might get on a math test. So we do construct the equivalent square using a right angle, and then they call it base and height. But you never get away from it's one side times the other side for whatever shape you're doing, okay? So when you look at those formula sheets, it can be confusing at first, but the reason they're just like area of a square, it's one side times the other, which the sides are the same, so s squared. Area of a rectangle, one side times the other, and you've got a length and a width because they're not the same. Parallelogram, you got to create your own right angle, which just happens when you choose the base and then draw at a right angle, straight up from that to the other side, you got the height. Triangle is also going to be the equivalent square, but only half of that. So triangle, you got to take half because a triangle is only half of the area of the equivalent square. Trapezoid gets fun. It's kind of similar to a triangle. Trapezoid has, trapezoid is like this. So it's kind of like a truncated triangle chopped off at the top. And then you have base 1 and base 2. So you have two bases, and you're basically taking the average of those two. One of these is base 1, one of these is base 2, and then the height is going to be a line that comes up from a right angle at a right angle to the other side. And so by averaging these two together, which that formula does for you, and multiplying it by this height, then you'll get the area of a trapezoid. So hopefully that will help explain these as you go through Give them a try. If you get stuck, shoot me an email. Use that great feature at WAMAP. I don't have a picture of it here, but message instructor. You don't have to type anything. Just send it to me, and I'll try to get back to you within 24 hours with a video and some help.